Rich Tehrani with TMC. We're at CES 2012, and on our show is Tracy Bilbrough with Switch Lighting. And Tracy, welcome to the show.
Thank you, Rich.
So light bulbs have been around for decades upon decades, and there hasn't really been so much innovation, but you've got something really cool and different that you had my editorial team buzzing about when you met with them yesterday, and so I'm glad I'm speaking with you today. Tell us what your company does.
Well, we set out to accomplish something that I think we have, and that is to replace the incandescent light bulb with a more energy efficient alternative that has no drawbacks versus the incandescent bulb. It can be used anywhere an incandescent bulb can be used. It can be dimmed on the existing dimming that's in place, and it is environmentally friendly, and it uses 80% less energy.
So really the best of all worlds, right?
Yeah, exactly. And there's been alternatives around incandescent alternatives. The CFL lamp, which has significant issues with it, doesn't come on to full brightness right away, isn't dimmable in most cases, has mercury inside, which is environmentally unfriendly. And so we wanted an energy efficient alternative to the incandescent that didn't have any drawbacks at all.
What about brightness?
We can put out the exact same lumens, which is a measure of light output, the exact same lumens as, in this case, a 60-watt incandescent. We have a 75-watt equivalent incandescent. That would be about 1,100 lumens. The 60-watt would be about 840 lumens. And we'll be the first people, we believe, with a commercially available 100-watt equivalent, which puts out 1,600 lumens. So the exact same light output and the exact same radial flux, which is the full distribution of light that you get out of an incandescent bulb.
Now, one of the challenges of this technology has been cost, and I've watched the cost curve come down slowly. Where are we talking about on the cost curve when we buy one of these, when it's available?
Sure. We're very sensitive to that because before there's a significant consumer market, we believe the retail price will have to be less than $20. Our bulb at launch today is in the low 30s, and for that reason we're primarily taking it to market initially to commercial end-use markets like hotels, restaurants, etc., where they use the light bulb so much every day that their paybacks are just a few months on energy savings. For the residential market, for retail and consumers, we think we can be to that sub $20 retail price in the back half of 2012. The volume that we will eventually build in manufacturing will help us do that, and also LEDs as a component part continue to come down a cost curve very similar to computer chips. So.
And there's a lot of, speaking of chips, a lot of chips in here, a lot of technology to enable this light bulb to do what it does, right?
Right. It's a solid state piece of electronics, really, and it's one thing that's going to change because of that is light bulbs are going to be moved from being a consumable to a consumer durable. This light bulb in residential use will live 25 years. So one of the things we say is if you put this in your baby's room when he or she comes home from the hospital after being born, he or she will still be studying for their college exams under this same light bulb.
Now, how do you test something to be able to predict the life of it?
That's a very good question. There's established tests, including ones that are done by Energy Star, if you're going to get an Energy Star label, that effectively uses somewhere between 3,000 and 6,000 hours of testing that they can extrapolate very accurately to 25,000 plus hours. And so we're actually going through our Energy Star certification right now. We'll have Energy Star before we launch it into the consumer market. But we've done internal testing both to the Energy Star standard, so we know it's going to pass, and we've also had our own life tests. We have some bulbs that have 14,000 hours on them already, which of course takes several years of continuous testing to get there, but we've been working on this bulb for several years.
And it's worth mentioning that one of the innovations is that there's a fluid inside there that one of the things the fluid does is it cools the light bulb down.
That's correct.
Right?
The key thing about getting sustainable light out of an LED chip and having it perform efficiently is to keep them cool. Like any solid state electronic, they run quite hot in their natural state. We are the only people using liquid cooling, and liquid, there's nothing more effective for cooling anything than liquid. That's why supercomputers are liquid cooled. That's why transformers outside on telephone pole posts are liquid cooled. That's why your car engines look liquid cooled. And we're the first people to apply that to a light bulb, the only people to apply it to a light bulb. And so we have about a 40% thermal advantage using liquid to cool the chips rather than just air and an aluminum heatsink.
Right.
And that brings us several benefits. The other benefit it brings us is that liquid acts as a secondary optic, and it throws the light in that full radial flux pattern that we're used to from an Edison incandescent light bulb.
And that liquid is, like you said, is something found in food, so it's not harmful at all. If it breaks, you just mop it up and you try not to step on it with bare feet until you get all the glass up, and you buy another one.
Exactly. We wanted it to be completely benign environmentally, both to the user and to the environment in general. So yes, this is a food-grade liquid that's in beer and pasta and women's cosmetics, and it's widely used. It's completely harmless, and even if ingested. And
it's heavier than a typical light bulb, and it's actually deceptively dense. I mean, it just is a real dense piece of electronics.
Yeah, it feels like people often say to us that it feels like a quality piece of consumer electronics, and it is, but it's not too heavy for any of the sockets it would go in, but it is heavier than you're used to from an incandescent light bulb.
And it's worth pointing out for consumers that this is actually a DC device, so kind of like I guess in the base of this device is the technology that you would think of when you have your laptop cord. That same brick that you have for the laptop cord that converts the AC power to the DC for the laptop is actually in here because the LEDs need DC power.
That's correct. That's exactly right. And it's one of the reasons why thermal management is so critical, because that's a component that's very sensitive to heat.
Sure.
And our thermal advantage, it means, for one advantage it gives us is that our light bulb can be used upside down, like in a recessed can or in a light fixture that mounts the bulb upside down. Most other bulbs can't be used that way. Incandescents can, but other bulbs with a driver can't, because the heat rises naturally. That's just physics, and
sure,
it kills the electronics in the driver. But we so efficiently manage the thermals, and we radiate a lot of our heat out through the liquid in the glass, that our driver will perform in that environment. So,
and anybody who's picked up one of those cords right after the laptop's been running for a few hours, or the bricks, knows that that's hot. It's a hot piece of electronics, and that's all right here. And so you've got light, which is generating heat, right? Because there's no such thing, right? It's not nothing's 100% efficient, so there's always a little bit of heat generated, and you got this heat, and so you end up with a pretty warm device if you don't have great technology behind it.
Exactly. And the goal is to get that heat away from the electronics, and that's what we do more efficiently than anybody else.
That's great. Did we miss anything, or did we get it all?
I think we got it all.
That's great. Well, congratulations. I'm looking forward to seeing these commercially available. I think it really makes the people in the green camp happy, and it makes the people that don't like fluorescence because mercury can poison you, makes them happy, and it makes people that are energy conscious happy.
It's the ideal replacement for the very inefficient incandescent light bulb.
Yeah, win-win-win. And I'm a big fan of 100-watt bulbs, so I'm looking forward to the 100-watt equivalent whenever that comes out.
Soon.
Great.
Okay.
Thank you.
Thank you.